Today we're going to talk about reaction rates of chemical reactions. And so this is all about controlling whether you can make a reaction go very quickly or very slowly. And there are many situations where we actually want to be able to control how fast or how slow a reaction occurs. For example, we want many chemical reactions to occur very slowly. We don't want our food to spoil, so we want those chemical reactions that cause food spoilage to occur very slowly. Alternately, sometimes we want reactions to occur incredibly quickly. For example, we want our cars to be able to move very quickly using the combustion reactions, so we must have the gasoline explode very fast. So that's why we would want to know how to control our rates of reaction. For this, we first need to understand what happens in chemical reactions. So in order for a chemical reaction to take place, the chemical reactants, they have to collide. They have to run into each other. It's kind of like a big game of Red Rover. The collision between molecules in a chemical reaction provides the energy needed to break the bonds that are in the pre-existing chemical molecules so they split apart into their parts, and provides enough energy that new bonds can be formed, so there could be new chemicals. Sometimes, even if there is a collision, there's not enough kinetic energy that's available to be transferred. So sometimes even those collisions, no reaction will occur. And so if you change how they collide, you can actually control how quickly or how many reactions occur, and how slowly, or reduce the number of reactions to make it be a slower set of reactions. So there are four key factors that affect our reaction rate. The first one that we're going to talk about is temperature. Temperature is a measure of how fast the particles in a substance are moving, on average. Higher temperatures mean that particles are, on average, moving faster, and if they're moving faster, they have more energy. Now, more energy means the collisions between the particles are actually more likely to make a chemical reaction. And conversely, having a low temperature means they have less energy, and that makes chemical reactions less likely. So in this case, where we have high temperature, there are going to be many chemical reactions occurring, and that means this is going to make a fast reaction. And in the second case here, where we have a low temperature, not as many chemical reactions are occurring, which means this is a slow reaction. The next factor affecting reaction rate is concentration. And concentration is a measure of how many molecules are in a given volume of solution. Higher concentration means that there are plenty of molecules that are available in each space that are able to react. This means a reaction is more likely to happen, and when reactions are more likely to happen, that means that we are going to have a fast reaction. Conversely, lower concentrations means that there are fewer molecules present. And these fewer molecules that are available in each space means that there are fewer that are available to react. And that means there are going to be fewer reactions. Fewer reactions means that it is going to make a slow rate of reaction. The third factor that affects rates of reactions is the surface area of an object. The surface area is a measure of how much exposed area there is on a solid object. So only molecules that are exposed to other elements or exposed to other chemicals have a chance to react, because they can't be collided with if they're not exposed. So having a high surface area makes chemical reactions more likely. Having a chunk or a large piece or piles of chemicals is going to make a low surface area, because there are large amounts of the chemicals that are stuck inside of the portion. And hopefully you can see in this demonstration here that while there is a flame being applied to this pile of flour, the reaction rate is fairly slow, that only the flour that's on the very outside of the pile is able to react, and all the flour that's on the inside is not able to react. This is a slow rate of reaction. Powders have a very high surface area. This is because all of the particles can be exposed to the other chemicals that are in the reaction. So as you can see here, when I sift the powder of flour, there's a lot of space in between, and in that space is going to be the oxygen that's reacting with the flour. When the powdered flour falls through that oxygen into some flame, that high surface area means that it can react rather quickly, and that's why you see the growth of flames where we didn't see it before on just the pile of flour. So controlling the surface area is actually a very important part of controlling the rate of reactions, and having a reaction that occurs too fast can be very dangerous. The last factor affecting reaction rates that we're going to talk about are catalysts and inhibitors. A catalyst is a substance that makes things easier for reacting. It, one way or another, reduces the energy required for a reaction to happen. It is an intermediary is the name for it, and an intermediary actually is not part of the chemical reaction. It does not become part of the products nor the reactants. It is just something that helps things along. An inhibitor is similar to a catalyst, but instead of making it easier for reactions to happen, it makes it harder for reactions to happen. So, a catalyst will help make fast reactions. An inhibitor will help make slow reactions. So let's just do a quick summary of our reaction rates. So when reactions are more likely, or when our reactions are faster, the temperature is high. The concentration is also high. The surface area is also high. And a catalyst is present. And one of the things that most people forget is, remember, powders have a high surface area. What are the conditions to make reactions less likely or to make reactions occur much slower? Is that the temperature is low. The concentration would be low, and the surface area would be low, and there might be an inhibitor present. And to remind you, surface area, low surface area would be things in chunks or pieces. These are just a summary of the individual conditions. You do not need to have all 4 conditions to have a fast or to have a slow reaction rate. These are just simply things that we can change. One of the most common things that we do is only change one of our conditions at once. For example, you want to keep your food from spoiling. There's a chemical reaction that'll make your food spoil. So what you're going to do is you put your food into the fridge. In this case, you're making the temperature low. By using this one condition, you have slowed down the rate of reaction, and your food will be unspoiled for a longer period of time. We didn't need to do all of the conditions. You can just do one at a time. I hope you found this to be fun. Have yourself a good day.